Casey from 7th Generation Design here. This is a quick video about a double fetch, as Bill Zedike would call it. In this case, what we're looking at is a triple fetch. Basically an issue where water is being gathered from the road surface, being discharged improperly, and ends up dumping back onto a lower switchback and compounding erosive force. So what you see behind me is actually the third place where this water could have gone off the roadway, but it's coming back onto the roadway and compounding its erosive energy. Just for size, like, you can get how big this erosion gully is and how deep it is. These are all tan bark oak roots that have been exposed from the soil lost. So we're going to start at the top and we'll walk our way back down to the bottom to show you how, through no malice, but through short-sighted or just narrow focused design, situations like this happen that ultimately end up impacting everybody that's using this road and endangering its function every time it rains. So here we are at the top of the problem area. This is where things start to go wrong. So we've got water coming down, trapped on the inside of this curve, comes all the way down here. A significant amount of the water stays on the road surface here. The rest transitions down here, where it'll lead to the first double fetch culvert. But this one right here is also a problem. So water stays on the uphill side of the road, but this is all silted in. This should all be an open trench. And believe it or not, right here is actually a culvert. You wouldn't know looking at it, but this filled in the last rain, flows right over, and then joins all the water on the road. So the culvert exit here isn't even visible too. So this culvert's entirely non-functional. And so all the water coming down both this private driveway, which catches everything uphill of it here, and then this section of the road, which brings not only this piece, but there's another property up here that is probably catching a lot of their runoff as well. This culvert's undersized and plugged, doesn't have a good enough grade, so it basically gets chock full of stuff every single rain, and then that water continues on down the roadway where it will lead to the second poorly placed culvert. So if we wanted to look at how to ameliorate this situation, it would probably mean replacing the culvert and increasing its grade so that it's cleaning, and then just being very attentive every storm, being out here with a shovel to make sure it doesn't clog up at the entrance. The other option, one that won't clog, is, since you'd have to tear up the driveway to do a new culvert anyways, is to put in a rolling dip here. You would take this water and transition it across the driveway. Just a very shallow grade, but with enough of a steepening and enough broadening of it so that cars could take it at high speed, and then it would discharge through this low point here. And this would make sure it never got back onto the roadway at switchbacks 1 and 2 down further that we'll see. So here we are approaching the second culvert. Drainage ditch on the side of the road. Everything seems to be working relatively okay. Some minor undercutting right here. Culvert's clear, all looks good, except this culvert only runs to right here. It's right behind this manzanita. I'll drop down here so you can actually see the exit point. The pipe lets out not more than 2 feet from the edge of the road. There's the edge of the asphalt. There's the culvert pipe. And wouldn't you know it, you have a about 6 foot, 8 foot deep erosion gully. I know it's very hard to see here at the camera, but right here, right below the frame, there's about a 6 foot vertical drop straight down. And all those, what look like branches running across it, are actually roots from manzanita bushes that used to be underground, but are now totally exposed due to the erosion. I'll see if I can work down there just to give you an idea of the scale of it. But this is a situation where the water should not be discharged this close to the road, and as we'll see in the next step, this water is all heading down. This giant gully is ripped open all the way down, and the next switchback below us, it's dumping right back out onto the road again. So here's the view from below. You can see the gully here in the foreground, and then as we move on up towards where the culvert exit is, right here, this is the initial 6 foot drop straight down. What needs to happen here at this second culvert is, instead of discharging so close to the road, this water needed to be brought out slightly off contour, but basically brought over here. This is actually the face of the ridge toe. bring it out here, and if there's a place to discharge it, at this area, over a broad area, so large scale perforated pipe or something like that, set on the level, but do it on the ridge, not in the valley bottom, where it's just going to rip open this huge gully. And obviously all that water, that was a, you know, an 18-inch culvert dumping out in one spot, and that we're on super fragile sandstone soils, so that needs to be dissipated. So what would probably need to be done is hook up a larger pipe here, somehow reinforce it so it can hold its own weight when it's flowing water, get it out here to the ridge, and then once it's there, set it out on the level, perforate it, drain that water in a really passive way over a very broad area. All this soil has been removed and gone down to the next switchback down below us. So here we are now at what you might call the triple fetch. We're once again one switchback lower on the road, and this is where that second culvert, that's where the drainage is coming down. And again, these are all, what are these, tan bark oak roots, all used to be below the soil. And if I could give you an idea of size, if I was to be standing in there, I would be about that tall. So this thing's 8 to 10 foot deep in places. It's a massive gully, huge amount of soil and really just rock. Now it's just down to subsoil, has been washed down. And then once again, we're here, so we've got this compounded problem on this lower switchback. What do we do with that water? I'll show you what's actually happening once it does finally get off the roadway once and for all. So this is just around the bend from that third collection point where we're back onto the road. Water's going to move through the drainage ditch here, and then finally it gets patterned off of the roadway this way. We're going to hike in through this, and I'll set up the camera again to show you what's happening just out of view over here. So here we are in the drainage ditch, which is soon becoming a gully, or quickly becoming a gully. This part here, you're seeing this is the original grade, so part of this had to be cut down in order to keep the water moving off the road, but that's well over 6 feet deep. That's probably 7 feet deep right there. To where I am now, you can look down, and again, you see massive erosion. Right over here is the original grade, and they didn't bring any equipment in here. This is all water doing the work. So grade was here, grade used to go right here. So all of that soil gone. And it's hard to see in the camera, but the water traipses down through here, and it's just incising an ever deeper path as it ultimately finds the valley bottom. So this is one example of where water concentrated becomes a really destructive force. Whereas if we were able to, one, keep the top culvert clear and have it functioning, or replace it with a rolling dip type situation, and at the second culvert we were able to pattern that water out across this ridge up here and get it up high over there, we'd be able to dissipate the concentrated energy of that water at several different locations, and we wouldn't be seeing this right here, where we literally have tens of tons of, hundreds of tons probably, of soil and rock just being washed away down towards the valley bottom, creating an ever more precarious situation here that could turn into head cuts and once again someday threaten the road, which is just up here.